Good morning all. Here we're going to run the Indramat servo drive DDS02.1-W100-D. Here's the shop's servo motor and the shop's bus power supply for this drive. This servo motor has an internal electromechanical brake, and when we place the drive in holding torque, you'll hear the brake release. Supply the control voltages, and the 223 phase to the bus power supply. And the drive has come up to AB in the 7-segment display. We're going to close the RF switch input by applying plus 24 volts DC to that switch input. Did you hear the brake release? Now, if you did not hear the brake release, we have a problem over here with the MOSFET that applies an external 24 volts DC through the MOSFET out to the electromechanical brake. Now we're going to run the servo motor by closing the AH switch. Now when I closed the RF switch, the 7-segment displays went from AB to AH. Now let's close the AH switch to plus 24 volts. The servo motor's running. The 7-segment display has gone to AF. I have a speed reference coming into the drive based upon plus and minus 10 volts from this power supply. And I can servo this motor clockwise and counterclockwise. Nice. I'll put the drawings of my hookups at the end of the video. Let's go over here and we're going to look at a MIDI Maestro DC drive. We got a lot going on today. Give me a sec to move the camera over to the next job. Here's our second job for the day, and we're going to run this DC servo drive, and it is type Maestro DCD 140 by 14/28. 140X 14/28. Now here on the data plate, it says that the minimum input AC voltage here on L1, L2, and L3 is 80 volts AC. The max is 120 volts AC. I have a 3-phase variac right here, and right now it's set to 0 volts on the output. There's 220 volts coming into the variac when I turn it on, and then I'll adjust this variac until I have 90 volts DC on the plus DC and minus DC terminals. I want to go to 90 volts DC on the DC bus of this drive because this is a 90 volt DC motor. I don't want to overvolt that motor. That's a nice motor. The tach from the motor is applied to terminals 11 and 12. Now, when we enable this drive to run, if this drive runs away, you can swap the tach wires or swap the armature wires. And after doing so, we should have control of that motor. I'll set it up so it'll run away, and you can see what a motor looks like when it runs away. But first, let's get the drive up and running normally before I do so. I'm going to go over here and power down that Indramat in the case that something goes bad here, because we're sharing the 220 line input, and if this drive flames out, I don't want it to cause that Indramat servo drive over there to hiccup. Be back in a little bit. There we go. Take my meter in voltmeter mode and get on the plus DC and minus DC terminals. I turn on the 3-phase variac. We've just applied 220 volts 3-phase to the variac. I'm going to adjust this up, looking at the meter, and when the meter tops out at 90 volts DC, there's somebody calling me. I'm a little bit busy right now. There, look at this. The green LED has just turned on. That green LED is drive healthy, and we're at 80 volts, 80.5 volts DC on the bus. Isn't that interesting? That data plate was correct. Turn that back just a little bit. We have 90.3 volts DC on plus DC and minus DC terminals. So that's as far as we're going to go with that adjustment of the 3-phase variac. Let's see what we got. Hey, look at that. This one's working. Nice. Only thing I did to it was blow the sawdust out of it. I like those kinds of fixes. Those are the easy ones. All right. I'll put my drawings of this one up at the end of the video, so that you can hook up your DC servo drive after you've performed your repairs, if any. Okay, all right, let's go find something else to do. I think we can. What in the world am I thinking? I forgot to set this thing up to run away. Okay, I'll slow that down just a little bit. We can servo back and forth, clockwise, counterclockwise with the speed potentiometer. Let me slow that down. Stop the drive with the enable switch. Turn the power off there. Now what I'm going to do is I'm going to reverse the tap wires. I won't let it run very long at full speed. Okay, the tap wires have been reversed. This is the reason when you disconnect this drive, if you undo these wires, inside the machine, when this drive is sitting in the machine, you don't want it to run away in the machine. It could tear some up, tear up the machine, and it could hurt some people. So you be very careful when you go wire this back up into the machine. The best thing to do is just undo these connectors and leave the wires connected. You don't need to send me the connectors. I've got plenty of connectors. So now the tap has been wired opposite of the way it should be. Now, when I enable it, that thing's going to run off. So I'm just going to enable it for a short period of time. See that? I have no control over that. And we got an alarm. That alarm is tack loss. Very smart drive. You swap these wires back, and we'll let it run for a while. Okay, we got everything back to the way they should be. Powered up the drive. Now we're in control again. So it's very important that when you wire up this drive, that the armature and the tack are wired correctly. Very nice running drive. After I get done running, I'll put the covers back on it. Oh, one more thing. Let me stop this. Stop that motor. Turn the power off. There's a personality card in this drive. The speed reference and tack runs through this card right here. It plugs into a connector. There's two little plastic guides that guides this into the connector. If you don't have this installed, this drive will not run. So if a customer ever sends this drive to you, make sure they leave this card installed. Let me power it up, I'll show you how it comes up. Notice that the green drive healthy LED is off. Let me go enable it to run. Nothing happens because this card is not installed. I believe they call that the daughter card. So this board must be the mother, and this little board's the daughter. Makes sense to me. There we have the card installed, the daughter card's installed, the green drive healthy light has come on, and we're running again. drives right here, they can be hard to work on because everything is surface mount. Get a picture of that and I'll show it to you. There's also ICs up underneath the daughter card. I'll get a picture of that too. Okay, now we're done. Again, folks, thank you very much for stopping by. We'll see you next time.